We are now going to look at finding the derivative of functions using the rules that we've learned, and they're going to involve, in this particular case, we see we'd need to know the derivative of an exponential, the derivative of a trig function, the derivative of a product, but also we now have some functions inside, and so we would also need the chain rule because we have a composition of functions inside of functions. So let's go ahead and find this derivative. So we first have the product rule, which is first times the derivative of the second, and the derivative of cosine of some stuff is negative sine of the stuff. You do not change the stuff inside when you're working with the outside function. The outside function is cosine u, so we leave that as negative sine u. Don't change the u or the stuff inside, but then we need to multiply it by the derivative of the stuff, and the derivative of 4t is 4, and then plus, because this was just first times the derivative of the second, plus the second, which is cosine 4t, the second function, times the derivative of the first. The derivative of e to the something is e to the something times the derivative of the something. There's our chain rule again. The stuff inside of the e to the u was negative 2t, so we needed to then multiply it by that derivative, and there's the negative 2 out in front. So we could express this as negative 4 e to the negative 2t minus, multiplied by sine of 4t minus 2e to the negative 2t multiplied by cosine 4t. Now it's fine to express it like this. It's also common to factor out common factors, and so this could be expressed as negative 2e to the negative 2t multiplied by 2e we could also express this factoring out a common factor, and so we would have negative 2e to the negative 2t, and that would leave 2 sine 4t plus cosine 4t, and either one of these is totally fine way of expressing the derivative. Now let's do the second one, and I'm going to express this as a rational exponent instead of a radical because we know how to deal with exponents with our power rule. So here is our function, and we actually have a function inside of a function inside of a function here because we first of all on the outside function have some stuff to the 1/2 power. So our outside function is something to the 1/2. Then as we move inside, we see that we have 1 plus 2, but we have this e to the 3x, so we have an exponential with some stuff inside. E to the something, and the something is 3x. So we're going to have a chain rule within a chain rule here. Let's go ahead now then and find the derivative. We start with the outside function, which is our something to the 1/2. So power out in front, decrease the power by 1. Do not change the stuff inside. When we're working with that outer function's derivative, the function inside does not change. Now we need to multiply by the derivative of what's inside. The derivative of 1, of course, is 0, and the derivative here we have a constant, so we have 2, and we have e to the 3x because the derivative of e to the something is e to the something, but then we need to go inside multiplied by the derivative of what's inside, and what's inside is a 3x, and so that derivative is 3. Finally, let's see what we can do to simplify here, and this 1/2 will actually cancel with this 2, and I'm going to get rid of the negative exponent, so it looks like in the numerator we have 3 e to the 3x, and then in the denominator we have the square root of 1 plus 2 e to the 3x. And there's our derivative.